Hey students, before you get this video started, make sure your math notebook is open in front of you. You're going to take these notes on the right-hand side, and you can use the left-hand side to answer those Edpuzzle questions or to write entry tasks. So the name of our section today is 2.1 Multiplying Fractions. And our learning target is I can multiply fractions by fractions, mixed numbers, and /or whole numbers. So we're going to be doing a lot of different combinations today with multiplying fractions, mixed numbers, and whole numbers. I think the best way to teach this to you is just by showing you some examples, showing you exactly how to do it. So we're going to start with our fraction by fraction examples. So in these ones, we were going to multiply together two fractions. Our first example problem is 8 over 9 times 3 over 4. To multiply these together, it's actually pretty simple. You just go across the top and across the bottom. 8 times 3 is 24. 9 times 4 is 36. But here's the problem. 24 over 36 is not in simplest form. We could divide both of these guys by 12 and get our simplest form fraction, 2/3. But sometimes simplifying fractions can be hard. So I'm going to show you the way that I think makes it a little bit easier. You might not think it's easier at first, but I promise it'll make it way easier if your fractions have really big numbers. So let's try it again. And the way that we're going to simplify this before we even multiply is by using something called cross-canceling. When we cross-cancel, we are basically simplifying our diagonal fractions and our normal and vertical fractions at the same time. So let me show you what I mean by that. First, let's look diagonally. So I look at the 8 and 4 and ask myself, what goes into both 8 and 4? The biggest thing that goes into both of them. Well, that would be 4. 8 divided by 4 is 2. 4 divided by 4 is 1. So look at that. I've already simplified my first diagonal fraction. Now I look the other diagonal way. What's the biggest thing that goes into both 3 and 9? That would be 3. 3 divided by 3 is 1. 9 divided by 3 is 3. And then last but not least, we just want to double check and see if there's anything to simplify up and down. 2/3 and 1 over 1. Nope, both of those are in simplest form. So that means we are ready to multiply. Again, we just go across the top and across the bottom. 2 times 1 is 2. 3 times 1 is 3. So look at that. We got our final answer, 2/3, and we didn't even have to simplify. We just used cross-canceling instead. There's actually a little song, too, that helps with cross-canceling. So I'm going to sing it for you, okay? Here's the song. And there's a little dance move, too. It goes, cross-canceling, not this way, it's this way. Okay, so it's not this way, it's this way and this way. Alrighty, let's try another one. We are going to do 3/7 times 2/3. And we are going to do this with cross-canceling. So that means I need to look this way and this way. What's the biggest thing that goes into both 3 and 3? That would be 3. 3 divided by 3 is 1. 3 divided by 3 is 1. Now I look the other direction, 2 and 7. What's the biggest thing that goes into 2 and 7? Well, the biggest thing that goes into both is just the number 1. And dividing something by 1 doesn't change the number at all. So we're going to leave those ones alone. We can't simplify them. And if we look at our up and down fractions, I can't simplify those either. So that means I am officially ready to multiply across the top and across the bottom. 1 times 2 is 2. 7 times 1 is 7. So our final answer is 2/7. Okay, now we're going to move on to mixed numbers. We are going to be multiplying mixed numbers by mixed numbers and mixed numbers by fractions. So our first example is 1 4/5 times 3 2/3. Just like with adding and subtracting mixed numbers, we first need to make these improper fractions. And remember, we use the acronym MAD. Multiply, add, denominator stays the same. 1 times 5 is 5. 5 plus 4 is 9. Denominator stays 5. And then with this one here, 3 times 3 is 9. 9 plus 2 is 11. Denominator stays 3. Now I'm going to cross cancel. So I look this way and this way. What's the biggest thing that goes into 3 and 9? That would be 3. 9 divided by 3 is 3. 3 divided by 3 is 1. Now I look at the 5 and 11. Those ones cannot be cross-canceled. The biggest thing that goes into them is 1. So then we move along and look at our regular vertical fractions. And again, I don't see anything that can be simplified. So that means we are ready to multiply. Across the top, across the bottom. 3 times 11 is 33. 5 times 1 is 5. But our answer is an improper fraction. And remember, we don't like that. So we're going to make this a mixed number. We need to figure out how many whole times 5 goes into 33. And then what is left over? Well, if I count by 5s, I get 5, 10, 15, 20, 25, 30. I can't do more than that or I'll be over 33. So that is 5, 6 whole times. 5 goes into 33 6 whole times. But that only got me to 30, and I have 33. So that means there are 3 pieces or 3/5 left over. We're going to try another one like that. We are going to do 4/9 times 3 3/4. So in this case, we're only going to have to change the one mixed number. We can just leave this fraction alone. 3 times 4 is 12. 12 plus 3 is 15. And then we're going to keep the denominator the same. So we had 15, and then denominator stays the same, 4. Now we look for cross-canceling. Look this way and this way. 4 and 4. What's the biggest thing that goes into 4s? That would be 4. 4 divided by 4 is 1. 4 divided by 4 is 1. Now let's look at 9 and 15. What's the biggest thing that goes into 9 and 15? That would be 3. 9 divided by 3 is 3. 15 divided by 3 is 5. And then if I look up and down, there's nothing else to simplify, nothing else to cross-cancel. So I'm ready to multiply across the top and across the bottom. 1 times 5 is 5. 3 times 1 is 3. But my answer is an improper fraction, so let's make it a mixed number. I ask myself, how many whole times can 3 go into 5? Well, only one time. But if we only had 1 3 that went into this 5, that means there's 2 pieces left over, or 2/3 left over. So our final answer is 1 2/3. And our last combination that we're going to do is fraction by whole number. Fraction by whole number. So this first problem is going to say 5 times 2/3. Well, in order to multiply these, I need them both to have a numerator and denominator. So I need to change 5, the whole number 5, into a fraction. To make any whole number into a fraction, you just give it a denominator of 1. So 5/1 times 2/3. Now let's look for cross-canceling. We're going to look this way and this way. 5 and 3, the biggest thing that goes into those is 1, so we leave them alone. The same happens with the 1 and the 2, and the same thing happens with our vertical normal fractions. So there is absolutely no cross-canceling in this one, and that is okay. That means we're ready to multiply across the top and across the bottom. 5 times 2 is 10. 1 times 3 is 3. And now to finish out this problem, let's turn this improper fraction into a mixed number. How many whole times can 3 go into 10? Well, if I count by threes, I go 3, 6, 9. That's as high as I can go without being above 10. So that was 3 whole times. But that only got us to 9, and we have 10 pieces. So we have 1 piece, or 1/3, left over. And our final answer is 3 1/3. All right, very last example. 3/7 times 7. We're going to start by making this whole number 7 into a fraction. Remember, just give it a denominator of 1. Now we look for cross-canceling. 3 and 1. There's nothing to cross-cancel there. 7 and 7. Well, we could divide both by 7. 7 divided by 7 is 1. 7 divided by 7 is 1. And then if we look up and down, there is nothing left to cross-cancel, so we are ready to multiply across the top and across the bottom. 3 times 1 is 3. 1 times 1 is 1. We have an improper fraction, so let's make it a mixed number. How many whole times can 1 go into 3? Well, that would be 3 whole times, and there is nothing left over, so our final answer is the whole number 3.